Hello friends, welcome all of you in my channel S&T PowerVision. In this video, learn about there are some number given, like we have to show that those are the irrational number. So I will show you how to prove all those questions here and what should be your approach here. So first question is root 6 here. We have to show that root 6 is the irrational number here. So what should be our approach here? So I have told in the beginning that suppose if there is any irrational number, so that can't be expressed in the form of P by Q. If it is a rational number, then only it can go further in the form of P by Q, where P and Q cannot be a common factor or cannot be simplified further here. So let's show that, okay, roots, just assume that root 6 is our rational number. If it is rational number, then it can be expressed in the form of P by Q here. Okay. So let's square both the side here. Square both the sides. So if the square of the square root of 6 is equal to 6, then it will be P square by Q square. I hope it is clear. Then just multiply it, P square is equal to 6Q square here. Or we can say that Q square is equal to P square by 6 here. Right? It means P is the multiple of 6 here. Correct? Since like both P and Q are the that is not common to each other. So P square is equal to 6 is Q square. If we transfer Q square equal to P square by 6 here. So it means P is the multiple of 6 here. Right. So we can say P is equal to 6K only. Just 6K is K here is an integer. Right. So P is equal to 6K. If we do square both sides, it will be 36K square here. Right. So it means P square is equal to 6Q square. From here we can take like P square equal to 6Q square. So we will take here 6Q square is equal to 36K square. Divide 6 means divide both the side by 6 here. So it will come here Q square is equal to 6K square. Right. So we can K square is equal to Q square by 6 here. It means Q is divisible by 6 here, right? It means 6, it means Q is divisible by 6 here. And also if you go this step, P is equal to 6K, it means it is multiple of 6 here. It means P is equal to 6K. And if you see this step here, here Q is divisible by 6 here. It means six is a common factor here. For both P and Q here. But it contradicts because when we assume that root 6 is equal to P by Q, that time we state that P and Q cannot be a common factor here. But here If we assume that root 6 is a rational number, it means 6 is the common factor to both P and Q. So both are the contrary, means it both cannot be true at the same time only. Right. So just say, like in our daily life, we can say at one point of time, I can go to only one place. I cannot be means at more than one place at the same time here, right? So here in the beginning, we assume that root six is a rational number. After the rational number means it can be expressed in the form of p by q here. P by q means that it cannot be common factor here. But after assuming that root 6 is means a rational number, so here that conclusion is coming that P and Q both having the common factor 6 here, means which is contradiction of each other only. So it means root 6 is our irrational number here, which cannot be expressed in the form of P by Q here. So now I hope it is clear. Now next question is we have to prove that 2 minus root 3 is a irrational number here. So remember one thing, like there are some formula like sum of rational number plus rational number is always rational number. It is also true in the case of subtraction, multiplication also. But when it comes to the irrational number, so sum of irrational number plus rational number is always irrational number. Okay, I'll show you how. Here first question is third second question, that is 2 minus same is also applicable in the case in the case of subtraction we cannot say here. So just say example here 2 minus root 3 here. If we see 2 is the irrational number, 2 irrational number, we can say 2 by 1 here. 2 by 1 here. It means 2 is the rational number here. Minus root 3. So root 3 is the irrational number here. So we have to prove that 2 minus root 3 means subtraction of means irrational number from the rational number is the irrational number here. So just assume that 2 minus root 3, if it is rational number, it means it can be represented in the form of P by Q, right? So we keep root 3 at one side equal to 2 minus P by Q, right? Yeah, P by Q is the simplest form here. It means it cannot be divided further here. Simplest form means the P by Q we can say P by Q equal to 2 by 3 here. We cannot divide it further here. If we just say like 4 by 6 here, means it can be divided here like 2 by 3 here. So P by Q is in the form of like this number 2 by 3 or 3 by 4 or 5 by 7, which cannot divide further here. It means here. So root 3 is equal to 2 minus P by Q here. Since Q and P are integer here, so we can say further like root 3 is equal to 2Q minus P by Q here. It means since Q and P both are the integer here, so 2Q minus P by Q is also a rational number here, right? So just say example like 2 by 3 here. So like 2 into 2 minus 3 by 3 is equal to 1 by 3. This comes under the rational number here. That's what we are trying to say here, the same thing about here. So 2Q minus P here, since P and Q both are the integer here, that is the simplest form here. So 2Q minus P is also a rational number here. But here root 3 is the means irrational number here. So both are the contradiction of each other here. So it means 2 minus root 3. See here root 3 is the irrational number here. And here it is 2q minus p by q is the rational number here. It is rational number. And root 3 here it is irrational number. Right. So both are like contradiction of each other. One side it is saying irrational number, another side rational number here. So both cannot be true at the same point of time here. It means 2 minus root 3 is the irrational number here. Okay, so this is the proof here. Now next question is 3 plus root. Third question is 3 plus root 2. We have to show that this is the irrational number here. So we'll assume that 3 plus root 2 is rational number. If it is rational number, so we can represent in the form of p by q here. P by q is the like not common factor, and that is the simplest form here. So we'll have the same approach here. Root 2 is equal to p by q minus 3 here. It is like p minus 3q by q here, right? Since here root 2 is the irrational number here, since here p and q both are the integer, if we subtract minus 3 from p by q here, so it will also come as the rational number here. Again, it is the contradiction of each other here. So it means 2 plus root 3 is, sorry, 3 plus root 2 is irrational number here. So we'll have the same approach here. So fourth question is 2 plus root 5. We have to show that it is an irrational number here. So again we will assume that 2 plus root 5 is the rational number here. If it is rational number, then we can represent in the form of p by q here. Right. So root 5 is equal to p by q minus 2 is equal to p minus oh, p minus 2q divided by q here. Since in the beginning we said p and q both are the simplest form and both are the integer here. So p minus 2q divided by q is also the rational number here. But another side root 5 is the irrational number here. So both are like contradiction of each other here. So we can say that 2 plus root 5 is also irrational number here. Next is the 5 plus 3 root 2. We have to show that this is the irrational number, but we'll assume that this is the rational number here. So we can say 5 plus 3 root 2 is equal to p by q here. So we can say 3 root 2 is equal to p by q minus 5. So p minus 5q by q here. So we'll simplify here. Root 2 is equal to p minus 5q by 3q here. So here as I said p by q is the simplest form here. So p minus 5q divided by 3q is the rational number here. Because p and q are both are the integer and in the simplest form here, it means we cannot divide it further here. here, but root 2 here is the irrational number here. So both are the contradiction of each other here. So we'll just simplify it like square root 2 of some rational form only here. Since both are the contradiction of each other, so these are 5 plus 3 root 2 is the irrational number here. Next is the 3 root 7 here. Means we have to show that this is the irrational number here. So we'll assume that p by q is the means 3 plus 7 root 7 can be represented in the form of p by q, where p and q both are the simplest form. Since p by 3q is the rational form here, so root 3 is also. But root 3 is the irrational number, so 3 plus root 7 is the irrational number we can say here. Like root 7 is irrational number here. But here it means p by 3q is a rational number. Next is seventh question here. We have to show that 3 root 5 is the irrational number here. Means if we divide rational number by irrational number or irrational number by rational number, so result will be always irrational number here. So if we represent 3 by root 5 divided means represented in the form of p by q, where p by q is in the simplest form here. So root 5 is equal to 3q by p here. Since p and q are the integer here, so p 3q by p is also means what to say in irrational form here. But another side root 5 is the irrational number here. So we can say both are contradiction of each other. So we can say 3 by root 5 is the irrational number. Yeah. Now, eighth question is 2 minus 3 root 5. We have to show this is the irrational number here. It means that this is a rational number. Means we subtract irrational number from rational number here. So this is also a rational irrational number here. So we'll show it here how. P by q here. Root 5 is equal to 2q minus p by 3q. Since in the beginning here p by q is the simplest form here, it means 2q minus p by 3 divided by 3q here. This number here, this expression here, this is the rational number here. But here root 5 is the irrational number here. Again both are contradiction of each other here. So means we can say here 3 by root 5 is the irrational number here. So here root 3 plus root 5 here. Ninth question is root 3 plus root 5. So both are the irrational number here. So it's sum of two irrational number is always the irrational number here. We'll show it here is equal to p by q here. So again root 5 is equal to p by q minus 3 square square both side. P square by q square here it is plus 3 minus, right. So we'll do the some adjustment here. 5 minus 3 minus p square q square minus 2 root 3 p by q here. So 5 minus 3 means 2 minus p square by q square is equal to, again multiply both side by minus here. Q by 2p here. Since p by q here we have taken in the simplest form here, both are the integer and simplest form here. So again here, if we say root 3 is the irrational number here, and here this is the means rational number here, since it is just like some multiplication of two rational number here. So both are contradiction of each other here. So again root 3 plus root 5 will be the irrational number here. So I hope it is clear.